Okay, NVIDIA has smashed their earnings. Massive interest coming into this earnings report, obviously, because we've been talking about NVIDIA. They've had a massive run up. Everybody is trying to buy capacity to run language models, et cetera, self-driving, yada, yada. And it's not just the Googles and Amazons of the world. You have startups trying to buy H100s, A100s, and buy this infrastructure. You also have sovereign wealth funds and countries buying these in the Middle East, in Europe, and you have traditional corporations buying them. This is the blowout of all blowouts in terms of performance. Q2 revenue, $13.5 billion, up 101% year over year. That's extraordinary on that large of a number, but up 88% quarter over quarter. High growth in stocks is 20, 30% year over year. So this is, just very uncommon, obviously. Q2 net income, $6 billion, up 843% year over year. NVIDIA is now worth $1.2 trillion. It's closing in on Amazon, $1.4 trillion, and Google at $1.7 trillion in terms of market cap. And here's the kicker. They're printing up so much money and so much profits, rather, that the NVIDIA board is approving a $25 billion share buyback. That's a very large number in terms of share buybacks. That's 6 times higher than what they were currently allotted. Yeah, I guess, Chamath, when you see this kind of extraordinary run-up, what is the ramification going to be in terms of for the industry, competition, and then just trading this name? Is this peak NVIDIA or is the peak yet to come?
Well, I think it's peak in one way, but this is less about a commentary on NVIDIA because they're clearly firing on all cylinders. But, it's a pretty well-established rule in capitalism, which is when the market observes that there's a company just printing enormous revenues and profits, they want to compete with them naturally to get their share of those revenues and profits. And that typically happens in all markets. And the result of that are just decaying margins. In the absence of a monopoly, this is what you should expect. And so because in this market, there's nothing really monopolistic about what they do. What they do is exceptional and good, but there are other ways and other systems and other companies that are developing chipsets and capabilities here to compete with NVIDIA. So it probably just motivates them even more and accelerates the path where you see competition. I tweeted this out yesterday, but one of the most interesting things that could happen is somebody like Tesla decides to either open source their chip or actually starts to sell their platform. Because if FSD gets to a reasonable level of scale, that entire platform system is a learning and inference system for the physical world. And I think that has tremendous applications. You have something called RISC-V, which is an open architecture spec to essentially compete and create different versions of different chips. That has implications more, I think, to ARM. You have companies like Google that, frankly, spun their own silicon a long time ago, TPU. You have Amazon now talking about doing the same thing. Microsoft has invested a lot of money in FPGA technology. So it's just yet another accelerant in this trend to create many forms of AI-enabled silicon. And so I think that sort of, it pulls that reality forward. And I think we're going to have to figure out when the market prices that in, because I think that probably decays the NVIDIA margin and upside over time. Again, that is not a commentary on them. That's just a market reality.
Yeah, margins get competed away. For folks who don't know, Tesla is making something called Dojo. It's their own supercomputer. Here's a picture of it. They showed that at Tesla AI Day last year. And you have ARM's open source competitor is the RISC-V chip you're talking about. It's an open source architecture for doing large jobs. And so I guess my question to you, Friedberg, is if you look at all this capacity coming online, do you think we're going to be in a situation where the amount of capacity, compute being put online, is going to outstrip the need for that compute because software is getting so much better? And then maybe people are running Hugging Face jobs and various LMs on the new silicon from Apple, and they're running it on their M2s. And so do we need this much capacity? Are there enough interesting jobs in the world for all this capacity? And then might that also be a headwind against NVIDIA when people say, I got enough capacity here?
I think the rational way to think about this is to try and calculate the efficient frontier on compute use. So the more compute you use, the more it costs you. The question then is, if you double the amount of compute you're using for a particular application, do you get twice the return on the investment? If you triple it, does your ROI on a percentage basis, go up or go down? So at some point, you reach an efficient frontier, which is you start to see a declining or negative rate of return on the investment in the compute that you're using for a particular application. And this is certainly going to be application and market specific. It's going to be largely driven by the data that is available in that market to do training, to do tuning, the market's appetite to spend money for that particular set of applications that emerges from that compute that's being used. And so we don't know today where the efficient frontier is across each of these different markets and sets of applications. And the market is finding that out. In the process of finding that out, everyone is spending a shit ton of money on compute. And they are trying to get as many server racks as they can. They are trying to get as many chipsets as they can. They're trying to get as much server time as they can. And everyone's got this idea that the more compute I can throw at a problem, the return is going to scale linearly. And it turns out that, like with most things, the answer is likely not. So we're at this point right now in, I would argue, a bit of a cycle that there looks to be a bubble. And what I mean by that is that there's a lot of inefficient spending going on as the efficient frontiers are discovered across all these different application sets. And so my intuition, without a lot of actual data to back this up, is that based just anecdotally on what I'm hearing people doing in the market, what companies are doing, what startups are doing, et cetera, everyone is throwing everything they can at compute, and they're going to realize that they're going to need to rationalize those expenses at some point. So I would envision NVIDIA is probably riding a little bit of a discovery of the efficient frontier wave right now, and that this probably is not necessarily steady state.
Sachs, we experienced this before, as you remember from the dot-com era. There was a massive investment, very similar to this, in fiber, and the overspending of building the fiber infrastructure so everybody could get broadband and they could stream movies, et cetera, happened in that 97 to 2002 time period. A lot of those companies went out of business. A lot of that fiber never got used. People were working on compression algorithms while they were building out massive fiber, and a lot of that fiber got sold. I think Google bought up a lot of it. Other people bought it up. And it was just a massive overspend. So is this like the dark fiber of this era where we're just going to build so much capacity that there's just going to be not enough jobs to run on it in your mind?
Well, I think it's a little different than fiber in the sense that every year there's going to be a new generation of chips. And so these cloud providers who are providing GPU compute, they're going to want to keep upgrading the chips to be able to address the next generation of applications. So I don't think it's quite as static as fiber where you kind of build it once. And you're right that there was kind of a glut of capacity that was created. Eventually, though, the internet usage grew into that capacity. But I think this is a little different because, again, you're going to need to upgrade the chips every year or two. I think Freeberg is right that this is clearly a spike in demand that may not be sustainable. I mean, recall what happened here is that ChatGPT launched on November 30th last year and really caught everyone by surprise. It kind of took the world by storm. And over the next few months, you had hundreds of millions of users discover AI. I think it surprised even the OpenAI team. I think when they launched ChatGPT, they thought it'd be more of a proof of concept, but it ended up being a lot more than that. And so everyone has scrambled all of a sudden in the last 9 months or so to develop their own AI strategy. And so, again, it was this giant platform shift that happened overnight. So there is a tremendous GPU shortage right now. And that's also what's leading to these almost software-like profit margins by NVIDIA. Because when everyone's clamoring to get a limited supply of these chips and there just aren't enough, NVIDIA can almost charge whatever they want. And so I think even more than the demand, the profit margins might not be sustainable. But I think the reality is we just don't know what the steady state of demand in this market's going to be. I think we can say that it can't continue at these growth rates, but probably there will be some steady state of demand that's, it probably is at least where we are today.
Yeah, I don't think it's perfectly analogous, Chamath, but just to bring up some historical context, check out this article I was reading the other day. The dimensions of the collapse of the telecommunications industry. This is August 2002. And it says the dimension of the collapse in the telecommunications industry during the past 2 years have been staggering. 500,000 people have lost their jobs. In that time, the Dow Jones Communication Technology Index has dropped 86%, the Wireless Communication Index 89%. These are declines in value worthy of comparison to the Great Crash of 1929. Out of the $7 trillion decline in the stock market since its peak, about $2 trillion have disappeared in the capitalization of telecom companies. 23 telecom companies have gone bankrupt in a wave capped off by the July 21st collapse of WorldCom, the single largest bankruptcy in American history. So just a little history there of this. It's not perfectly analogous. Obviously, NVIDIA is not going bankrupt or anything like that, but this overcapacity issue is definitely going to be something. But you had mentioned that in one of your tweet storms in the past couple of weeks, or these long form that you're doing on X, previously known as Twitter, you mentioned that what are the jobs that could be pushed to this compute? And what if one of them works? I think you were doing a speaking gig that somebody tweeted out a little clip of. So let's unpack that. What do you think are some jobs that people might push here that we don't anticipate that could solve something miraculous in the world?
Well, the framing is really like if you go back to like the gold rush of the 1800s in San Francisco, the people that made the money were the platform enablers, right? They were the ones that sold the picks, the shovels, the pans, and the jeans, right? And that's where Levi Strauss was born. The equivalence in that analogy today is NVIDIA, because they are the dominant pick and shovel provider. So the question is, well, what are we going to use these picks and shovels to create? Are we going to find gold? And I think the question is unclear. And where will that gold be found? Will it be found inside of a big tech company, or will it be found inside of a startup? If you look inside of where these resources are being used inside of big tech, it is to completely scorch the earth on the economic value of large models. And I think that that's very, very good for all of the startups that come after it. So what do I mean by this? We were all so wrapped around the axle around ChatGPT and then GPT in general. And now, if you look at the quality of Llama 2, basically these big companies have decided, no, we're just going to make all these models extremely good, extremely useful, and very, very free. And so a lot of the resources are going there to economically subsidize, and by implication, economically destroy the value of that category. That's going to be good for startups. And so the question is, what will you then build on top of these quasi-free, almost free tools? And so one area that I have been looking at for a while is in computational biology. I think that clip that you're talking about was just me talking with Oren Zeev, just around the ability to compute large complex spaces with very sparse information. It's a very difficult task today, but tomorrow in an AI model that you can train, you can literally characterize every single molecular permutation you could imagine. You combine it with something like AlphaFold, and you can understand protein folding, and all of a sudden you can sequentially start to put tools together that could theoretically give you much higher probability guessing for specific compounds that could actually cure disease. A different version of that is a company that myself and a few other people started. I tweeted that out, which is more in the material science space. And we've had some pretty important breakthroughs there, which is really about trying to invent next generation battery materials. And we have one candidate that could be pretty revolutionary if it turns out to work. We don't know yet. Some positive signs. So there are some of these green shoots. So my perspective is that a lot of the money that NVIDIA makes today is going to be money well spent, because it'll be going to the big guys, big tech plus Tesla. They are then going to create some really foundational platform technologies with it, whether it's Dojo, whether it's FSD, whether it's the full platform inside of Tesla that is the cameras plus the inference plus the training for all forms of physical world interaction, whether it's Llama 2. And all of that stuff will be given away essentially, I think, open source, quasi-free to the ecosystem over the next few years. And I think that'll be a really important moment, which will create hundreds of new companies doing really clever, cool things. So we haven't yet seen the big breakout company yet. And so I think that right now, most of this CapEx is going to the big guys, but the dividends of all the work that these big guys are doing will be seen over the next few years in the startups that get started in the next 4 or 5 years.
I love the California analogy. Ultimately, what all that prospecting for gold did was create the state of California, putting aside the Levi's and the jeans. And if you know anything about California's GDP, it would be, I think these statistics are always talked about, 5th, 10th, 8th largest. It has a bigger GDP, California, than some of the largest countries in the world. So This is a 2015 chart. It's hard to find the updated information on this, but ultimately that was the product of the gold rush, is this incredible state. Any other thoughts on NVIDIA before we move on to ARM?
I think OpenAI had a potentially significant product announcement that's related to this. So they just launched fine-tuning for ChatGPT, actually version 3.5 Turbo. It says here, fine-tuning lets you train the model on your company's data and run it at scale. Early tests have shown that fine-tuned GPT 3.5 can match or exceed GPT-4 on narrow tasks. So you can do things like fine-tune the formatting of the output. You can fine-tune the tone. Fine-tuning also allows businesses to make the model follow instructions better. So I think the point of this is that we're still at such an early stage of this, and there are so many applications that are going to be developed, and they're making the models more and more useful. So Jason, to your analogy about fiber, what happened with fiber is there was a big build out of overcapacity, but then the number of applications kept growing until that capacity got used. And I think we're probably going to see something like that here, where there is a big build out going on of capacity and capabilities, and that's going to lead to the next generation of applications. And I just think we don't know yet what the steady state of either demand or supply for these chips is going to be. Obviously, the market got taken by surprise over the last year. So you've seen, again, this huge spike in demand. The supply cannot react fast enough. That's led to gigantic profits for NVIDIA. But it's hard to know exactly, again, what is the steady state going to be? Is it going to be like this, or is this a one-time spike? And we also don't know what the supply will be once the manufacturers all adjust, because now they know that the demand is there.
And to your point, like the big use cases are pushing us well past chips to really be more like entire systems and these racks. And so if you look like at Grace Hopper, which is their next gen design, it's like a bunch of chiplets plus memory on any huge board. It's not a chip. You're talking about system level manufacturing at this point. And that will also create different kinds of use cases. Because, for example, today, right now, when you look at simple things like probabilistic tasks, I think ChatGPT and all these GPTs are pretty marvelous and pretty inspirational. But deterministic tasks, they're shit. Like, they hallucinate on simple things like multiplication. Why? Because you infer multiplication and you try to calculate it probabilistically and you get these simple math functions wrong. And so these are all these things where the software has to become more and more sophisticated and actually be able to path and tunnel code into different ways of getting it executed and then bringing it back and stitching it together. All of these things don't exist. Those are very rudimentary things that were solved in V1 of compute. So I think that, to your point, David, like, we don't know where this goes. We're probably going to go to a place that it's not just about chips, but it's about systems. But that's going to create this weird balkanization almost. And I think that's where a lot of the profit margins will get eroded away, because that will make it a much more competitive industry. And there just isn't a lot of margin to capture when you actually stitch all these things together.
Yeah. And if you think about what were the massive wins for all that extra fiber, it was really two companies. The first was YouTube, which stopped charging people for transport on their videos. Before that, if you had a video go viral, your server got shut down because you hit your $5,000 a month limit or whatever you had set with your ISP. And then Netflix, of course, right? Netflix couldn't exist, and all that dark fiber built that. So we'll see with all this extra GPU, what could happen. And to your point about the breakthroughs there, you can now go into your ChatGPT and you can put in custom instructions. And so it asks you, what would you like ChatGPT to know about you and to provide better responses? And, for example, I told it I'm a venture capitalist. I live in the Bay Area. I'm looking for concise business information. And then it says, well, how would you like ChatGPT to respond? And I said, I like to see data in a table. I like to see data in those tables with hyperlinks. I like citations when possible.
Yeah, just to be clear, what you're describing with custom instructions, that was a feature I think they launched like a month or two ago.
A couple weeks.
What that is doing is prompt engineering, basically. Yes. It's pre-saving like all that preamble that you would have to put in every single one of your prompts.
Yep.
Whereas this fine-tuning, as I understand it, is more about fine-tuning the model to improve the model for a certain kind of data, or certain kind of output.
Right. So the example there would be if you had your email box, or you had your Google Docs, or you had a repository of all your Slack messages or something in your company, you had your company handbooks, or all of Chamat's letters he writes every year, you could have that uploaded to ChatGPT.
It's potentially very powerful, I think,
Yes.
for enterprises. I think the big enterprise use case, the most obvious one, is that every enterprise wants its own internal chatbot. It wants its own internal ChatGPT where the employees can ask questions and the AI has access to all of the company's information and it understands permissions and privacy. So it only reveals information to people who have the right to see it. That's kind of a tall order, but I think that's what the market wants.
Yeah.
They want the ChatGPT for the company intranet.
Yes. And so
I think there's a lot of
it,
people racing to provide that. And there was an interesting tweet by Nathan Benach. Anyway, he just said, bye a bunch of startups. Because I guess a lot of startups were working on this fine-tuning problem. That may be too glib a
Yeah, it's way too
reaction.
glib.
Because I think there's just a lot of enterprises who do not want to share all of their corporate information with OpenAI.
Of course. What if it's HR information? And then you got people asking, like, who are the most overpaid people in this company? You know, what if it's like the badge information and how many hours people are working? Or
That's more about permissions, Jason. But
Sure.
even if OpenAI can nail the permissions problem, I think there's just a lot of enterprises who will not want to trust their data to
Of course
OpenAI.
not. Yes,
They're going to be
of course
afraid
not.
about where it goes. This is why I think open source is taking off in a big way, is that I think big enterprises would much rather roll their own models and control it and do the fine tuning. And that's why they're using tools like Mosaic and Hugging Faces. They want to have control over it themselves.
That's an excellent point. And that has implications as well into the hardware, which is also probably a good jumping off point for ARM, because what you said is exactly must happen for the integrity of an organization to want to use these things. And if that happens, then it just further accelerates, I think, how the hardware will get abstracted and, frankly, quasi-open sourced as well.
all right, let's talk.
Facebook did a great job of this because, like, when Facebook was building data centers, they had to invent tremendous capabilities that didn't exist before. And the market was really fragmented. It was very expensive. And what they did was they basically created these reference designs for servers and blades and the whole 9 yards and open sourced the whole thing. And it just, in essence, destroyed a market, but it created a hyper-efficient market that then everybody could use. And I think the question is that if it's happening at the software layer already now, just like it did in Web 2 software, and then we see certain elements of Web 2 hardware being open sourced, I think it makes pretty logical sense that you can expect the same things to happen in the AI world. The AI models and the AI platforms and all of that stuff will first get open sourced because it's a data integrity security issue. And then the hardware will get open source as well because you just want simple reference designs you can use and plug and play.
Yeah, if you want to look at that, it's called the Open Compute Project, opencompute.org. Just a way to use open source to grind down the prices, take out the margin, I guess is what you're saying, Chamath, to make all these data centers scale, right?
Well,
and so
one related story here is this just happened in the last few weeks. There's a company called CoreWeave, which provides cloud infrastructure for AI training. It secured a $2.3 billion investment in the form of a loan. What CoreWeave is trying to do, it's kind of like AWS, but for GPUs. So essentially, instead of having to buy your own GPUs in order to, set up your own infrastructure, you just basically rent compute from these guys.
But this is exactly why, like, none of these companies will really be allowed to exist in this exact way 4 or 5 years from now, because ultimately what people want is massive throughput, right? Tokens per second. Give me as many tokens per second as possible. And they don't particularly care. Again, if you understand the model, do they really care what the underlying substrate hardware should be? It doesn't seem like they should. They should care what is the throughput, what do I pay for it? And by the way, that is exactly what happened when AWS really started to scale. Because if you guys remember, when we started to first abstract code into AWS, what did we care about? How much did an EC2 instance cost? How much did an S3 bucket cost? And that's all we cared about. Because that abstraction allowed us to not care about the underlying hardware. Who was the vendor? What was the configuration? It didn't matter. And so in an interesting way, we're going to go through that same evolution here because it's just economically rational that kind of a market exists. You should only care tokens per second, I think.